Beginning 6-7, inverse functions and relations, I first want to talk about what an inverse function is. Think multiplication. So when we talked about multiplication, just a refresher, when we talked about an inverse, we would talk about something like this, where we would have 2/3, and then the inverse of that would be 3/2. And when we multiply those together, we get something that equals to 1. So that's an inverse when it comes to inverse fractions. There's also inverse operations. It's opposite types of things. So when you're talking about inverse functions, the key here is when you find the composites of inverse functions, in other words, when you kind of put them together or multiply them, so to speak, you end up with a 1x or just an x. And we'll talk about that later. But inverse functions are just kind of like opposites. Okay, that's what we really want to focus on, is how in our fraction example, the numerator became the denominator and the denominator became the numerator. Well, in this first example, just to kind of get you an idea of what an inverse relation is, or an inverse, this is just a relation showing you some x, y values. To get you started, an inverse relation is when your x values and your y values are interchanged. They're basically change places. And that's what we're going to notice here when we go down to our equations as well. So for this first example, all I'm going to do, instead of having the coordinate point of 0, -1, over here, the inverse of that is just -1, 0. And then my second point, instead of 2, 0, it's now 0, 2. My third point, instead of 3, 2, it's now 2, 3. My fourth point, instead of 4, 3, it's now 3, 4. So just keep in mind that inverse, I don't want to say it means opposite, but just kind of think in those terms, opposite. Okay, opposite. We're kind of changing around our x and y values when it comes to relations or when it comes to functions. We're going to be changing around the x and y value. So as I move on down into the notes, we're going to talk a little bit about this. I know the properties are always confusing, but I do want to talk about it. I'm not even going to talk about the words up here because there's a lot of stuff up there that you won't necessarily understand until we go through the example. So let's talk about inverse functions, and they are written, I should have fixed this in the notes. It is written like this, not written like that. This little -1 represents the inverse of x. And let me show you what. We talked about negative exponents mean they need to go to the denominator. So f of x, and then we have the inverse of f of x. And if we brought that up to the top, it would be f of -1. Okay, so just kind of showing you that why those are inverses and why we notate them the way we do. So moving on to this, so let f of x be x minus 4. And then its inverse, which should have a -1 there, you probably can't really tell, is be x plus 4. So we're going to say that x minus 4 is the original function, its inverse is x plus 4. And I'm just going to show you how we can prove that they're inverse values. So if they are inverses, so I'm going back to this right up here. Okay, if they are inverses, then when we use a as an x value and we come up with b as our y value, we should be able to flip-flop that, and we should be able to take y as our x value and come up with, take b as our x value and come up with a as our y value. So here's an example where it says evaluate f of 6. So I'm going to take my f of x equation or function and put 6 in, and I end up with 2. So when x is 6 in this function, y is 2. Well, over here in my inverse function, I should be able to take my y value, I should be able to put this in, because remember we talked about in the table, we took our original ordered pair and we just flipped it. So I'm going to take that as my x value. I should come up with the 6 as my y value. Well, when I put that into my inverse function, that's exactly what happens. So that's just kind of showing how inverse functions work. My function, all of my x values that I put into my original function should generate some y values that when reversed would work in my inverse function versus for x and y values. Okay, so let's do some examples and we'll kind of talk about it a little. I think it'll make more sense. The first thing I want you to be able to do is find an equation for the inverse of a function. So if your instructions and some of your assignment will tell you find the inverse of f of x equals 4x plus 12. Well, the first thing I want you to do is I want you to take this f of x and I want you to replace it with a y. So that's what I did right here. I replaced my f of x with a y. My step 2, exchange the x and the y. So I leave everything else exactly where it is, and I put the y's in where the x's were, and the x's in where the y's were. And then step 3 is I solve for y. So now I'm going to subtract 12 from both sides. So over here I get x minus 12 equals 4y. And then I have to divide everything by 4. Okay, so because I know I have to divide this by 4, so I got to divide my x minus 12 by 4. So now I've solved for y. There's the inverse. So then my step 4, do not forget this step 4. So let's go ahead and replace that y with the inverse of f of x. So I would basically take that y out and say the inverse of f of x is x minus 12 divided by 4. Now, finally, is the inverse we found a function? Let's review what a function means. A function is where you have every input has one and only one output, or every x value will have one and only one y value. So no matter what I substitute in here for x, I'm going to subtract 12 from it, divide it by 4. This is a function. Okay, my x is not squared. I'm going to be able to substitute in, and every x value will have only one y value. That's the definition of a function. You're going to be asked that later, and we'll kind of go through these as we go. Hopefully that kind of makes sense. Have one and only one y value. Moving on. Next example, another one, find the inverse. So again, we're going to rewrite the equation with a y instead of our f of x, and then we're going to trade places with everything. So our x goes where our y is, and our y will go where our x is. And then we're going to solve the equation for y. So I'm going to multiply both sides by 3. I'm going to get 3x equals y plus 6. And I'm going to get 3x minus 6 equals y. And my last step is I'm going to say 3x minus 6 equals the inverse of f of x. And this is a function. This is a linear function. We just graph a line. So it definitely is a function. Okay? If you had an equation that looked like this, just want you to know you can find the inverse. It does the exact same thing. However, my x is no longer squared, and now my y is squared. And I would still just solve for y. So I just want to toss that out there because you will have some examples like that. I know it's not on your notes, but you will have some examples or some problems like that in your work. So from here, how do I actually solve for y at this point? Well, I take the square root. So I get y equals the square root of x minus 6. That would be the inverse of this problem right here. This would not necessarily, we won't talk about it being a function or not, but I think it could be a function because the x is not squared. Okay? All right. Moving on. Example 2, composing or verifying. This is where we're going to determine if they are inverses. So this kind of goes back to the very top of the notes where when I put their functions together, so to speak, I find the composition of each function. I end up with, when I do f, the composite of f and g of x, I get x. And when I do the composite of g and f of x, I get x. And I'll show you what that means. But if both of those composites end up just equaling my 1x, both of them, then I have inverse functions. So let's just suppose my f of x is 8 minus 4x, and g of x is 2 minus 1/4 x. So I'm going to try to do the composite of f of g of x first, which means I'm going to do this. Basically, my g of x equation becomes my x value in my f function. So here's what it means. So f of g of x means this. My function of f is 8 minus 4x. So everywhere I see an x, I'm going to put this in for it. because the g of x is my x value right here, in this right here. So I'm going to take that 2 minus 1/4 x and put it in for the x. And I'm going to solve. I'm going to distribute the negative 4 through. So negative 4 times 2 is negative 8. And then negative 4 times negative 1/4 is positive 1, so that gives me a positive 1x, or just x. We really don't need the 1. I'm just showing you. Sometimes you guys still write the 1. Okay. 8 minus 8 is 0, and 0 plus x equals x. So this one came out. The composite of f of g of x does equal x. So let's go over here and try it the other way. Let's try the composite of g of f of x. So g, this time my f of x function is going to be substituted in as my x value in my g of x function. So this time I have 2 minus 1/4 x. Well, my x is going to be my f of x function, which is 8 minus 4x. So you guys, this is just my f of x function right there. And again, I'm going to distribute. So negative 1/4 times 8 is negative 2. And negative 1/4 times negative 4 is positive 1. So positive 1x. 2 minus 2 is 0. 0 plus x is just x. So both of these came out when I did the composites of each of them. They simplified to just 1x. So since both of them simplified to just 1x, they are inverse functions. Again, if you have questions, please write them down and ask. Last problem. So this is kind of similar to what we did in 6.6 when we were finding composites of functions when we actually were given an x value. The thing is, we're doing the composite of f and its inverse. Well, they give us f right here, but they do not give us the inverse.
Coach Perry, please contact the office.
So we have to first find the inverse of x. We have to find the inverse of f of x. So again, I'm going to go ahead and start right here. I'm going to exchange out my f of x with a y, and then I'm going to change places, and I'm going to solve for y. So I'm going to get x plus 8 equals 8y, and then I'm going to get x plus 8 all divided by 8 equals y. So, and I can say instead of y, again, I can now put this. It's important that we label this because I now have my f of x here, and I have my inverse of f of x there. So now I can actually do this. Okay? So I'm going to take my, substitute my x value into the inverse equation. So here's my inverse equation. So I'm going to substitute that x value in. So I'm going to get negative 8 plus 8 over 8. And that equals, well, negative 8 plus 8 is 0 over 8, which equals 0. So when my x value is negative 8, my y value is 0 when I'm using the inverse of f of x. So now I figured this out. So now I'm going to take this value and I'm going to put it into my f of x, just like we did in 6.6. I solved this value first, or that function first, and then I took that value and put it into the second function. So now I'm going to put in, oh, sorry, I need to put the 0 right there. So f of 0 would be 8 times 0 minus 8. And I get 0 minus 8, which equals negative 8. What do we notice? The input of negative 8 became my output when I used it, when I put it into the composite of f, the composite of the f of x and the inverse of f of x. I wonder if that's true. As you go through your practice today, see if you find that to be true. I think generally speaking, and that it makes sense because if my input is 0, my output should be negative 8. Inverse functions should look like this. That's exactly what inverse functions should look like. So just kind of think about that as you work on your worksheet or you do your Math Excel. If you notice right here, you're working with inverses, think about what you might possibly find right there. If that's your input, it also could be your solution.